Hello, Assalamualaikum. My name is Muhammad AZMI bin KHAIRUZZAMAN. I am from BEEI2463. Okay, today I will talk about conduction graphical analysis on heat transfers. First, I will introduce my members, which is consists of NUR'AIN HANZALAH bin RAMLI, MUHAMAD ZIKRI bin Muhammad JOHARI, MUHAMAD FATEH bin HAMID, NUR'AIN NATASHA binti Abdullah, MUHAMAD ADHAM bin FENDI, and myself Muhammad AZMI bin KHAIRUZZAMAN. For introduction, in heat transfer, fin surface is one of the designs that help to transfer heat away from a hot device. It is able to enhance convective heat transfer through increased surface area to volume ratio. Fins provide additional surface area for heat exchange with the surrounding air. The design consideration include fin geometry, spacing, and dimension. For objective, to create two different fin surface according to our creativity using SolidWorks software. The second one is to perform heat transfer simulation process using SolidWorks software. Okay, that's all from me. Next,
for the problem statement, enhancing heat dissipation in electronic systems. In modern electronic systems, the increasing power density and shrinking size of component generate excessive heat. And then, the accumulation of heat leads to performance degradation, reduced lifespan, and potential system failure. After that, for traditional cooling methods are insufficient to efficiently dissipate the heat generated by this component. After that, for the specification, for ambient temperature in Kelvin is 301.15 to 307.15, and then for convection coefficient is 5.03 watt per meter square dot K. And then for average temperature on call site is Celsius. It is 76.6, and then a fin base size is 40 mm times 40 mm. For average heat flux on cold site is 1500, and then for average temperature on cold site is 97.3 Celsius.
I will tell you about material, what material that we will use, which is aluminium alloy 1016. The property of this material is shear modulus, and the value is 2.7 E plus 10 Newton meter per square, and mass density is 2700 kilogram meter cube, and tensile strength is 68 million 935,600 Newton meter square, and the we use compressive strength, weight strength, thermal expansion coefficient, thermal conductivity, specific heat, and material damping ratio in this property. And next, we go to the design of this material, which is spiral fin surface and Y fin surface. The width for spiral fin surface is 40 mm. The length is also 40 mm. The height is 42.01 mm, and the diameter is 15.61 mm. Meanwhile, while Y fin surface is the width is 40 mm, The length is 40 mm and the height is 27.78 mm.
Hello and Assalamualaikum. My name is Muhammad bin RAMLI. My matrix number is B0821103884. Okay, now for the result for spiral fin, the temperature is at minimum is 40.4 Celsius and at maximum is 40.9. The minimum is on top and the maximum is at the bottom of the spiral fin. As you can see here at thermal versus temperature versus distance plot, the temperature, the highest temperature is 40.90 Celsius for the distance from 0 to 1 parameter distance. And here for heat flux, you can see the arrow going spiral upwards and the minimum heat flux is at 29.4 and the maximum heat flux is 5.68 exponent plus 0.3. And that's all for the result spiral fin.
Okay, Assalamualaikum. My name is NATASHA and I will present to you the result of the Y fin. As for the result shown for Y fin, the temperature minimum is 34.7 degrees Celsius and maximum is 34.9 degrees Celsius. The heat flux shown, the minimum is 24.4 and maximum is 2.95 exponent plus 0.3. And also for the graph of temperature versus distance, show that the shorter the distance, the highest the temperature of all. That's all from me. Thank you.
Assalamualaikum. My name is MUHAMAD ADHAM bin FENDI and my number metric card is B0821100497. And I would like to present for discussion part. For our material, the boat design use the same material, which is aluminium alloy, which commonly used for manufacture. And next, for the surface area, the design with more surface allows it to dissipate through fins more efficient. Fin geometry, which is choose fin shape based on available space. Next, for the design, for the fin spacing, it is optimized spacing for airflow and surface area trade-off. Then, for the fin thickness, it has a balanced thickness for heat conduction and convective heat transfer. And next, for the conclusion, the design of fin surfaces in heat sinks is crucial for efficient heat transfer by optimizing fin geometry spacing, thickness, and length along with careful material selection. This design and surface enhancement heat sinks can effectively dissipate heat. Considering airflow, heat sink size, and manufacturing constraints further enhance their performance. A well-designed heat sink contributes to improved thermal management in electronic device and systems. That's all for me. Thank you.